All right, we are beginning the recording. This is Code Archaeology, Digging Up the Past with Paul Kowalczyk, building official, plans examiner, architect, and all-around knowledgeable guy who, with a deep love of history, this is a great presentation. I know I learned a lot watching it, and I know you will as well. This
All
is
right,
the
is it
final
up?
class of the day. Your presentation is up, Paul.
All right,
If
perfect.
you need anything from me after this class is over, I will be in office hours till about 5:30.
All
Thanks
right,
so
thanks a lot,
much.
Ming. Thank you. Well, you've almost made it to the end of the day. This is now your last class of the day, so thanks for sticking with us all day today. I introduced myself earlier this morning, so I don't need to go through that. Um, kind of explained who I was. So let's just jump right into this class. This is Code Archaeology, Digging Up the Past. Kind of this class, the objective is designed to take the student through a historical journey through some of the major tragedies that ultimately resulted in code changes to the building and fire safety. Um, I think a lot of times when we can use historical background, we can really understand what's in the code. And towards the end of the presentation, I'm going to explain a little bit about the importance in being involved in the code development process. So I often think, can building codes be interesting? I've been in code enforcement for over 20 years, and I know when you open up a book and maybe you read it and go through it, it's really not the most exciting subject out there. But I think, did you ever sometimes look at those codes and wonder how a code section came to be? And I think in order to understand what's in the building codes and some of the other codes is we really need to go back in time. Now, I'm a big history buff and I really enjoy reading history. I enjoy historical nonfiction. And I've always been fascinated with the European theater during World War II. And I read so many books on that subject. And many years ago, Google or Amazon is a great tool to kind of suggest new books for you to read. And so I was looking for my next new book to read, and they suggested that I read a book called The Coconut Grove Fire in Boston. How that all works with Google and Amazon, I don't know, but I looked at this book and I looked at the brief description on it, and I figured I'd give it a shot. It was the first book I ever read about a building tragedy. And reading this book, it really piqued my interest. As I'm going through the book and reading what is happening as that building is going under fire, and I could start to see many of the failures in the building system, I could really begin to link this with my job as a code official. And so, just like a lot of the world and American history books that I read over the time, I also began to notice that there were many other books out there written on numerous other tragedies that occurred throughout the world. And so, as I started picking up these books, I read many of the books over the last decade. And a couple years ago, I decided there was so much information on this, and it actually led to a lot of what's in the code today. So I thought, why not put a class together? And that's why I'm speaking with you today. So I think from an early age, we've learned that a strong structure is important for protection. And we didn't need to understand the building code. Same with these guys. I think even if we do not understand building code, we understand the need for buildings to be strong and safe. These are the places where we live, work, and play, and building codes are the parameters to guide the designer and the builder with the roadmap to a safe building. But how did these codes come to be? Codes have been around for many years. They just didn't come about in the 20th century. A lot of times codes were the results of tragedies that ended up in code changes. And it is often said that codes are written on the backs of dead people. But I think if you went into every single code book and pulled out every single little section, each section would have its own history. So what I'm going to try to do throughout this presentation is reference the applicable code sections from the Ohio building codes. And I think this is an attempt to give you a better reference in how some of these codes historically were developed over time. And what was really the intent or the history behind a lot of what we enforce today. Now, some of you may just be getting into code enforcement. As I've said, I've been in this business for over 20 years, and a lot of times I've heard inspectors out there, when they're trying to tell somebody what they have to follow, they just kind of say, as a code official, because that's what the code says. But I think, wouldn't it be better, instead of saying that's what the code says, to really know the history behind the code? Because I think when we understand and can explain how that code came to be or why it's there, it really makes that code more understandable, more interesting. And I think the person that you're trying to get them to comply with kind of remembers this for the next time they go around. And I think it can add to a teachable moment in the field with a contractor, a building owner, or a resident. I really think, being out there with a contractor, and when they ask you something, and instead of just saying, because that's what the code says, when you can explain to the contractor the meaning behind the code, it's no longer just a governmental command, but I really think it becomes a thought out reason. I'd recently read an article on a code professional that said he wanted his building department to be an information center and not a center of regulation. And I think that really goes to what you'll be talking about in class on Friday morning with Jerry Flanick about inspector skills. It's really not, it's really not our job to be out there saying, do this because the code says to do it. It's more of, here's the reason why the code is telling you to do it. And I think when we understand the meaning and can explain the meaning to people, it really does add to more credibility for the code official in the field. Back in January of 2018, in the Residential Code of Ohio, they had a lot of updates that came into play. And one specific update that came into play in January of that year was this section 502.6.3. This was a change that just occurred in the state of Ohio. It was not an ICC code. It was something that somebody in Ohio decided to put in there. And within that same month that this code section went into play, I actually received a call from an architect, a call from a structural engineer, and I was actually questioned about it when I was out in the field by a contractor. What this new code section said is, a lot of times as we're putting up the foundation walls and we start to set the steel beams that are resting on those foundation walls, anytime you run into an open corner where that beam kind of sits in that open beam pocket, starting in 2018, that beam now had to be physically attached to the wall, like we see here. Now, what had happened prior to that, what actually led to that code change, was that there was a house in Ohio that was under construction, and there was a beam sitting in an open pocket, and I believe that had a walkout basement in this foundation, and the contractor happened to be in the house. The first floor deck was up. They were starting to put the walls up, but there was a contractor who kind of drove the Bobcat into the walkout basement, actually had his bucket lifted up, and as he was driving through the basement area, the bucket caught onto one of the steel beams, and because it was sitting on an outside corner in an open beam pocket, and it was not secured to the foundation wall, that actually pulled the whole floor structure down, and all the walls that were starting to be erected, those fell down as well. And so the whole reason behind this is, as that building is going up, we still want to make sure that that's a safe environment. And that's why this code change came to be. And so now when the architect, the structural engineer, and the contractor had asked me why this code change was there, I was able to explain to them, this is why we're doing it. It's not just because somebody wanted us to make this code change, but there was really a reason behind why that came into play. What I've done in this presentation is stayed with a chronological order. This course could never cover all the tragedies and events that have occurred throughout the world. Let's talk a little bit about the first building code that we know of. It was actually the Code of Hammurabi of 1760 BC. And under this code, there are 282 laws. And of those 282 laws, 6 of those laws related strictly to building construction. Um, and those dealt with consequences of the building failure rather than safe building. And if you're reading the legal aspects of code enforcement, they do discuss this code as being one of the firsts. And there was some understanding that you, as the builder, had a responsibility if you were building a structure that people went into. And this one specific law stated that if a builder builds a house for somebody and does not construct it properly, and that house which he built falls and kills its owner, then the builder shall be put to death. Sometimes when I read that, I wish we still had that code into effect. Maybe we could stick that in chapter 1 of the building code, and then the jurisdictions around here would not be required to have contractor registration. What about building codes in the Bible? If you actually look in the Old Testament, Deuteronomy chapter 22, verse 6, there is a quote in there that says, when you build a new house, put a parapet around the roof. Otherwise, if someone falls off, you will bring blood guilt upon your house. So even in the law of Moses, there is a construction reference. And if you think about this, this was written in 1400 BC, which is over 3,400 years ago. Now, how does that 3,400 years ago play into the code today? Basically, in the Ohio Building Code, section 1015.2, basically when we're up on elevated areas that are greater than 30 inches above the ground, we are required now to put guards along those open walkways. We want to make sure that people don't fall. And so who would have even thought, that we could have traced this code section back to the Old Testament? So next time, if you're ever out on an inspection and you have to cite somebody to install a guard around either the open edge of a roof or around a rooftop unit that needs to be accessible, you can just tell them that the Bible is making them do that. The Greek philosopher Socrates, one of his quotes was he had stated that he shall set the joints against each other, fitting, and before inserting the dowels, he shall show the architect all the stones to be fitted, and shall set them true and sound and dowel them with iron dowels, 2 to each stone. And when you read that, that sounds to me like the inspection process. Before we put it all together, before we grout everything, before we close everything up, make sure the architect comes out and looks at everything. And similar today, in our administrative section of the building code, it is the duty of the owner or the owner's representative to cause the work to remain accessible and exposed for inspection purposes. So going back to Socrates, this section goes all the way back to that. So well before the 3 little pigs understood the meaning of a strong house, there is evidence that the erection of safe structures was an idea going back thousands of years. So let's look back in history on some of the early tragedies that shaped the need for some building codes. We've already discussed the code of Hammurabi in the Bible, but one of the earliest events that shaped the built city was the Great Fire of Rome. This occurred in July of 64 AD, and there was over 70% of the city was destroyed. Rome burned for 6 days and 7 nights, and some say that Emperor Nero had actually started this fire in a means for greater urban renewal. At that time, Rome was a city of 2 million people, and thousands were living in poorly constructed buildings in the slums. Once the fire started, it just consumed all these poorly constructed buildings. Of the 14 districts after the fire, only 4 remained, and 3 were completely destroyed, and 4 were reduced to ruins. So in the aftermath of this fire, the Emperor Nero, as part of his urban renewal, started looking at houses needed to be constructed further apart. Instead of wood structures, we should start constructing our buildings in brick. And actually, roadways should be increased in size so that we can get people through the city or out of the city should there be a major event. So we can see early on there is a recognition to get away from clustered buildings and provide ample space between structures. So about 1600 years later in London, in September of 1666, we had the Great Fire of London. And this fire destroyed 13,000 houses, 87 parish churches, and affected over 70,000 people. And what's interesting is this is occurring about the same time that we are starting to expand over into the United States. Things were occurring that began to shape the way we started looking at future building in our communities. For the Great London Fire, the fire started in a bakery and the wind started the flames to conflagrate to other structures. Once again in London, we had narrow streets, overcrowding, poor people still constructing their houses with wooden thatch. And we did have some wealthy individuals who had the means to build them out of masonry. But early on in a lot of these disasters, what we are starting to see is conflagration is the major theme in a lot of these terrible events. In the aftermath of this fire, the rebuilding of London required them to have wider streets, to have open and accessible access to the River Thames. So in that case, there was a means to get water should there be a fire. Again, starting to think about having access to water to put out these fires. And they started really pushing to have houses constructed of brick and stone. So again, about the same time over in the early colonies, in 1678, we were having a lot of fires in Boston. Many of the houses that people lived in, again, were wood frame houses and they were being burned down. As we know, in a lot of these earlier houses, fireplaces were the essential means for cooking and heat. And a lot of the roofs were made of wood or thatch. What we actually found out was early on in a lot of these houses, the chimneys were actually made out of wood. They were wooden chimneys. And what the practice was is you had a wood frame chimney, and then you actually did like a cement parge inside that interior of that chimney flue. But like anything else, these chimney flues needed to be maintained. Over time, that cement parging on the interior began to crack and fall apart, and it actually started to expose the wood frame of that chimney. So we saw so many houses being burned down in Boston due to these wooden chimneys, and the fact that we had a lot of thatched and wood shingle roofs, that the city of Boston came forward and started to ban the wooden chimneys and required all roof slates to be used with tile material. The Brick Act of 1811 was in Newburyport, Massachusetts, and this was an event that a fire ravaged through the city, destroying over 250 buildings. After this terrible fire occurred, the city got together and said, we really need to start looking at moving away from wooden structures. There was a stable that was set on fire by an arsonist, and again, there was a strong wind blowing that night, and 16 acres were consumed in the fire. Once again, conflagration was the culprit in this event. The Brick Act established that brick and stone be used in construction. If you were having two houses or two structures built next to one another, you needed to construct a firewall. And they also started limiting the height of structures so that if there was a fire, the firemen would be able to reach the top story of these structures. Similar to the previous act, in 1814, Portsmouth, New Hampshire also enacted their Brick Act because their city had three major fires in 1802, 1806, and 1813. This Brick Act created a fire zone which would allow wooden structures to be built, but they were limited in size and limited to only being constructed in one story. There was a lot of outcry when this went into effect because this was a town that was built on the water, and most of the carpenters in this town were shipbuilders. And typically a shipbuilder is somebody who works with wood. And the last thing you want to force a carpenter to do is tell him that he can't build his house out of wood, that he needs to build it out of brick or masonry. And so again, there was much outcry against this act. In that same year, we had the burning of Washington, D.C., where the British burned down many structures in the city as attack on the War of 1812. Numerous public buildings were damaged by the fire, including the White House and the Capitol building. So cities are beginning to realize that there are issues when constructing with wooden structures. As we have these fires, when the communities start to rebuild, we look at widening the streets, putting restrictions on wood. Masonry becomes a mean to provide separation between structures. And we really are starting to see cities develop restrictions around buildings constructed with wood. So if you jump all the way up to today, what you see as a result of wooden structures is that when you go into our height uh, area tables, the number of stories, how tall you can build a building, how large you can build a building, you will find out that when building with wood construction, this is the most limited of all the construction types. And so when you look at these charts, it makes sense that based on our history, when a wood structure is under fire, it will collapse pretty rapidly. And because of that, we don't want to build these buildings too tall or too big or multiple stories. What is interesting, though, is, as I said earlier today, on Friday, we went into the new code cycle, the 2024 Ohio Building Code. And we used to have a type 4 construction, which was called our heavy timber. Those were the old buildings that were basically built with brick exterior walls, and all the interiors were heavy wood timber structures. We now have a type 4 A, B, and C construction, because what we're seeing now is what's called a mass timber building. And these are structural members made out of pre-engineered wood, and we're putting them together just like we put steel structures. So what we're finding is, although it's a wooden structure, it is pre-engineered and they're much stronger. And so when you build out of those wooden structures, you can actually go quite tall with those structures. But again, if we're just stick building a structure, we limit those just because of what we've seen in the past. Also, as a result of this, if you look in the fire code section, we want to make sure that if a structure does have a fire, that the fire department can readily access these structures. So even in the fire code, we look at roads. If we have a road that comes to a dead end, we have to put means in place that we can get safety vehicles to the end of that road, but we can also get them back out of that road. And so again, we're trying to make provisions so that should there be a fire, we can get vehicles safely there. Fire separation, there's nothing wrong with building buildings up to a property line, but the closer we get to a property line, we want to make sure that if there's a fire in the building that we've built and it's right on the property line, we want to make sure that that fire doesn't hop over that property line and catch another building on fire. And so what we've done is that as we get closer to the property line, we have to really increase the fire resistance rating on that exterior wall. We also have to begin to look at openings in that exterior wall as we get closer to a property line. In this example right here, it shows us that if we have, maybe that's a 2-story building and it has a roof, but the building next to it is much taller, and those buildings become close to the property line, what we have to think about is if that smaller building catches on fire and that fire penetrates that roof, there's a good chance that that fire could move over to the building next door. And so we have to start looking at, if we are going to put openings in that building next door, we have to do protective openings limited to the size, where they could be located. So what we are trying to do is minimize any type of risk should there be a fire. And again, this all goes back to all these earlier tragedies that we saw relating to conflagration. Today, if we are putting 2 structures up against one another, fire walls have to be built of any non-combustible material. So in most cases, when we're building buildings, a lot of what we see is masonry being used as a firewall. but in a lot of our townhomes, we do have non-combustible material, and that's basically a shaft wall assembly that's put between those units. So again, we want to make sure that, yes, you can put buildings up against one another, but we want to protect them that should there be a fire on one side, the building on the other side can remain. Now we're going to shift a little from construction and actually go into these next examples that will actually deal with the interior environment of the structures that we live in. And we'll find these in Chapter 12 of the Ohio Building Code and Chapter 3 of the Residential Code of Ohio. In the late 1800s, many buildings were constructed in New York City to house multiple working class families. We saw a large population of working immigrants coming here to the United States, and we needed to house those. You had a lot of private landowners who were starting to build what's known as tenement housing for these working class folks that were coming into America. These buildings were known as tenements and are known as some of the worst housing that was ever built in our history. These buildings lack the basic need for light, ventilation, and sanitation. And I'm sure if you Google it, I mean, these pictures, these were structures that people actually lived in. But we really had no regulations up until this time. So private landowners really maximized what they could build on their properties. And there were really no laws out there that told them how they had to build these structures. And so in 1867, the city of New York came up with the first Tenement Housing Act. What you can see in this original plan of these tenement houses, they were long, narrow buildings, and basically in the front and the rear of the building is where you had your windows. So that was the only way that you could get light into these long tenement houses. So all the interior rooms had no light and had no proper ventilation. So this Tenement Act required that, one, they were going to start installing fire escapes from every building so that should there be a tragedy, there was a way to get out, not just from inside the building. Every single sleeping room had to have a window. Up until this time, there was no requirement to have any railings on the stairwells. And because we didn't have indoor plumbing, for every 20 people that lived in your structure, you had to provide one outhouse. And again, more pictures. If you look at these pictures, you have your outdoor outhouses for these buildings. And on these inside, there wasn't much ventilation. A lot of these interior rooms were dark because they had no access to natural light. Well, they went through that first reiteration with the first Tenement Housing Act, and they found out that it really wasn't complete enough because now they just felt that, okay, we're giving buildings the means to have windows. So everyone just kind of pushed their bedrooms to the front and rear of the house, but that all interior rooms needed to have windows, and all windows needed to face a source of fresh air and light. And so what the designers came up with is what we know as the dumbbell design. But it was found shortly after they started building these dumbbell designs that it really only benefited those people who were living on the top floor. And so as you look at this plan, you know, these are two units stacked next to one another. But if you just look at one of the units, the floor plan does look like a dumbbell. And what they did was started to introduce these interior courtyards so that every single room on that entire floor would have some type of access to a window to get light and fresh air. But could you imagine looking at this building, the taller you get with that building, those people living on the first couple floors, even though they were facing an interior courtyard, those courtyards were so small that there was really no light getting to any of those units. Maybe the top 2 or 3 floors had some light, and maybe you were getting some circulation. But what they were also finding out is a lot of these courtyards were used where people were throwing their trash down. So the people on the lower floors ended up just closing out those windows. And if you look at this picture, actually looking down one of these shafts, you can see that it doesn't take much going down too far until it becomes pretty dark. So really, this dumbbell design really did not work. You weren't really getting the required light or ventilation of fresh air into these rooms. So in 1901, they actually came out with a new Tenement House Act, and it actually banned the dumbbell design. And now they started looking at floor plans that either resemble the letter H, C, I, or L. Many of these buildings started to be constructed on corner lots so you could take advantage of the two street frontages. And this was just another example of how they started to, they really started looking at increasing the interior courtyards and making them much bigger so that you truly could get light and fresh air down to the lower floors. So looking at all this, when we go into chapter 12 of the Ohio Building Code and chapter 3 of the Residential Code of Ohio, we can see now that in any type of occupied space in a building, we need to provide a means for natural ventilation through windows, doors, louvers, or other openings to the outdoors. And then every space intended for human occupancy shall be provided with natural light by means of exterior glazed openings. So we have recognized that natural light and ventilation is very important to provide a good interior environment for human habitation. We talked about those courts between buildings. Early on, those courts were really small, and they recognized over time that those courts had to increase in size. And so in today's code, it actually states that courts shall be not less than 3 feet in width, and courts having windows on opposite sides shall not be less than 6 feet in width. Courts shall not be less than 10 feet in width unless bounded on one end by a public way or yard. And for buildings more than 2 stories above grade, that court shall be increased 1 foot in width and 2 feet in length for each additional story. So what this code section is saying is that, yes, we can make the building taller, but as that building gets taller, our courts are going to get much more bigger and wider so that we can actually get that light and air circulation down to the lower floors. So the results of a lot of the things that came out of the tenement housing deals with, in chapter 12, we have ventilation of our spaces for occupancy. There needs to be temperature control to provide heat within these buildings. You need to have lighting. We have restrictions about yards and courts. We want to make sure that there's sound transmission. We're not carrying heavy sounds between units. That all rooms have minimum space size requirements, and that all our facilities that we live in have toilet and bathroom requirements. And again, this is chapter 12 of the Ohio Building Code, but all these same issues are covered in chapter 3 of the Residential Code of Ohio. So now we're going to go to the Chicago fire of 1871, which was October of that year. And there was over 300 fatalities. Over 17,000 buildings were destroyed, and this fire covered a 3.5 square mile area. As a result of this fire, there were over 100,000 people were left homeless, and $200 million in damage, which would be worth $4 billion today. There always was the legend of Mrs. O'Leary's cow knocking over the lantern and causing this fire. But again, Chicago at this time was a congested city of wooden structures. At this time, we had months without rain, and there was actually a major fire elsewhere in the city the night before. Now, actually, 2 days before this fire, on between October 8th and the 10th, there were actually wildfires raging throughout the upper Midwest region, including Illinois, Wisconsin, Michigan, and these wildfires swept throughout this region. About that time, the weather conditions in these areas were prolonged drought. There was a lot of logging going on in these areas and clearing of land for agriculture. And at that time, we had higher than normal air temperatures and strong winds, which contributed to these fires being swept through the upper Midwest and into Chicago. As I said, there was a fire in the night before in Chicago, and fire crews were exhausted, and a lot of their equipment had been damaged. And again, we had strong southwest winds. At that time, many of the streets were covered with dry wooden planks because of mud, and fire service response was not immediate for this great fire because of what had happened the night before. After this fire swept through Chicago, the city started looking at reconfiguring the city into a grid that would ensure firefighters being able to get in and around the city. We also started looking at Chicago, looking at the maximum distance from any point in an apartment building to an exit door. So we wanted to make sure that if you were in an apartment building up on the third or fourth floor, that you didn't have to go very far to an exit door. A lot of the tenements that were in the Chicago area were torn down and replaced with 3-story flats so that fire departments would be able to access the top floors based on the size of the ladders that they had at that time. Fire escapes were required on buildings as a second means of egress, and we started looking at large diameter water lines were starting to be placed around the city so that the fire department would have access to a higher pressure. And as these buildings were starting to rise into Chicago, as we started to see the early goings of skyscrapers, we started requiring fire hoses to be put into these larger buildings. In 1872, the Chicago City Council directed all new construction to use fire resistance material, and terracotta became a very popular material. As we were building these buildings much taller that were constructed out of iron and steel, in order to protect that under a fire event, we needed to cover those with brick and terracotta. So what we can relate to in today's code, going back to that time, is if we go in our chapter 7 of the Ohio Building Code, based on the structure of that building, we have to make sure that we can protect that structure under a fire event. And so whether it's a wood structure or a steel structure, how can we prevent that, protect that in a fire situation? In section 905, we talk about standpipes. We have to be able to get that water up to the top of a building. And so certain criteria requires us to have standpipes going up through stairwells. In chapter 10, the number of exits, we have to make sure there are plenty of exits to get people out of the buildings and have a certain amount of access to access doorways. And then also exit travel distance. We can only go so far in order to get to a exit. And we also want to see in the fire code that there is a protection of the water supplies that are coming to these fire hydrants. So now we're actually going to leave the United States and jump over the pond to England in 1883. And this was actually a stampede. It really wasn't anything that happened with a building. It wasn't a fire or it wasn't a collapse of a structure. But what it was actually 183 children died on this day from compressive asphyxia. And this was an afternoon matinee. And what the promoters of this afternoon matinee were hoping for is they didn't think they would get a lot of attendance. And so what they went and they did was they advertised that they were going to give out prizes for this afternoon matinee. Well, because they did that, they actually received more attendees than they actually could put inside this auditorium, but they felt bad and they did not want to turn individuals away. One of the safety issues is within this theater and auditorium space, they had upper gallery levels, and those were accessed by stairs. But at the bottom of these stairs, these doors did not swing out at the bottom of the stairs. They actually swung in. And these doors were actually wedged shut so that they were trying to keep more people from coming into this space. At the end of the event, there was actually a stampede. As you can see, there were upper levels, and when they said they were going to give prizes out, a lot of the children on the upper 2 levels thought that because they weren't close enough to the stage, they might not be able to get prizes. And so there was actually a panic and there was a rush to get down to that lower stage level. And so as the children and patrons started running down the stairs, it was happening so quickly that the people at the bottom of the stairs could not get that door open. And the amount of people kept running and running and running towards that stairwell. Um, so what had happened is there were a lot of children, and 183 children had died from being compressed. And we don't think much about that. Could that really happen? So what was a result of this tragedy? It actually created what we call the crash bar. And in 1908, this was developed by Carl Prinzler, Henry DuPont, and the Vonnegut Hardware Company, which is today known as the Von Duprin Company. As a result of this, now we have doors that are, all doors shall be swinging, and they shall move in the direction of egress travel if there's an occupant load of 50 or more. And swinging doors, which serve an occupant load of 50 or more in either an assembly type building or in a school, shall be provided with panic hardware or fire exit hardware. And we often think that event actually occurred in 1883 in London, but in November, just a couple years ago, in 2021 in Houston, Texas, there was actually an outdoor concert. And again, there was a rush of all the people within the crowd, and there were not enough exits to get out of that outdoor area. And so we ended up with 6 people who died from being compressed, and 300 were injured. In September of 2022 in Guatemala, again, there was another outdoor concert, and they didn't provide enough exits out of that concert venue. And again, 9 people were crushed and 20 were injured. And in that same year in South Korea, there was a Halloween festival, and this actually occurred within a street area. But again, there were so many people and not enough places for these people to disperse from. And so again, we had 156 people died from being compressed and 150 injured. So today, when we look in the fire code, we actually do have a section for crowd managers for gatherings exceeding over 1,000 people. And so where facilities or events involve a gathering of more than 1,000 people, we have to have crowd managers in place so that we can properly know how to disperse people and safely get them out of these areas in the event of a tragedy. In Chicago, in December of 1903, we had the Iroquois Theater fire where 575 people died in that fire. 30 suffered injury as a result of the fire and eventually died. And it was the deadliest theater fire in the United States. And it's the deadliest single building fire in the United States. Beautiful theater in downtown Chicago. This theater had a capacity of 1,600 people. And on that afternoon performance, it was estimated that there was roughly 2,100 to 2,200 people in attendance. So we had 400 more people there that should have been in that building. It was standing room only, and many of the patrons found themselves sitting in the exit aisles. This theater only had one main entrance into and out of that building, and there was a common stairwell that ignored the requirements for separate stairs and exits from each level of seating. So we had an upper level, but it also only had one way down from that upper level. This theater had no sprinklers, no types of fire alarms, a telephone, or any type of water connection. And they did have a fire warden who was employed by the theater. There were on the main auditorium level, the main floor level of the theater, there were exit doors, but they were actually hidden behind curtains, and they had no exit signs above them. And these doors were fitted with what was called a bascule lock. What that lock looks like in this picture is very similar today to what you would call a flush bolt type of lock. But again, even if you found this, that hardware has a lot of different contraptions that have to move. And so when people eventually found these locks, they did not know how to, it took them a while to figure out how to open those. So during the performance of this afternoon theater performance, there was actually a spark from an arc light behind the stage that ignited the Muslim curtain. The fire quickly moved up the flammable material behind the stage and caught the canvas scenery on fire, which filled the fly gallery. There actually was an asbestos proscenium curtain, but it was caught on the tracks and they couldn't get it to close. The entire stage area was consumed in flame. There were smoke vents in the roof of the fly gallery, but they were locked shut. Again, the intent of these smoke vents were to act as a chimney effect. If there had been a fire and those weren't locked shut, those would have opened and that would allow the air to escape out through the roof. But since those were locked shut, that fire behind the stage just kept getting bigger and bigger and bigger. When some of the exit doors on the theater floor were finally opened, the air from the outside actually sucked the fireball from the stage area into the auditorium area because, again, they couldn't get that proscenium curtain shut. It completely just engulfed the entire audience area in flame. In the aftermath, panic bars again were required on all exit doors in theaters. And also, egress doors shall be readily openable from the egress side without having to figure out a use, a key, or special knowledge to open that door. Manual operated flush bolts or surface bolts are not permitted on exit doors, and all exit doors shall open out. In today's code in chapter 4, when you look under stage and theater areas, we do have certain requirements for proscenium curtain requirements. They have to be constructed of a certain material and asbestos. For all the scenery that's behind the stage, we have requirements for how much and what type of materials those can be made of. And then as well, there has to be ventilation, stage ventilation, roof vents, and smoke control so that if something does happen, we can actually close that curtain and limit either the fire on the audience side or the fire on the stage side. It was found when they went back and did the investigation on this theater that it was claimed that it was an asbestos curtain, but they actually found out that there was very little asbestos found in that curtain. And even if it had properly closed, it would not have performed its duty on that day. It was also known that the codes in effect at the time were not properly enforced. During the court process, evidence was shown that building and fire code violations were known by the fire inspectors, but they were paid off with tickets to ignore these violations. Charges were filed on many of the individuals, but the defense attorneys dragged this process out for many years and said the fault was inadequate building and fire ordinances. So in the end, nothing really happened to any of the individuals that were involved in this terrible tragedy. So now we have the first printed building code in 1905, and this comes into play 2 years after the Iroquois Theater fire. And this was developed by the Fire Writers Under Association. And it is interesting. I would highly recommend, if you're interested in the first building code, to kind of Google this and you can find this. And it is interesting to see that in 1905, many of the similar things that we enforce today, they had the same concepts back then. But just one section that I wanted to pull out of this was basically section 161 talks about seals, badges, and uniforms. And basically it says that the Commissioner of Buildings shall adopt a seal and its direct its use in the Department of Buildings. And suitable metal badges of office shall be provided by the Department of the Buildings, and each badge shall be numbered for all officials of said department having the right to enter buildings or premises, and to be worn conspicuously by them during their hours of public service. Said badges shall be and remain the property of the building department. So even back in 1905, we talked about, when we go out in the field, we should always be carrying proper certification that shows us that we are part of the authority having jurisdiction. And if you look in the administrative section in Chapter 1 of the Ohio Building Code, it states that the building official or the building official's designee is authorized to enter the structure or the premises at reasonable times to inspect or perform the duties imposed by this code. So that first section pretty much mirrors what was said back in 1902. And what we say today, though, is that we still have to, provided that the credentials are presented, so we have to show that we actually have the right to be there and that entry is requested and obtained from the building owner. So in 1905, we had the National Board of Fire Writers wrote the first building and code. In 1927, we saw the International Conference of Building Officials establish what was known as the Uniform Building Code, and that pretty much got adopted along the West Coast. In 1945, there was the Southern Building Code Congress, and they established the Standard Building Code, which basically was a lot of the southern states. And then in 1950, the Building Officials Conference of America, known as BOCA, established the Basic Building Code. And that's what a lot of us in New England, up and down the East Coast, and in the Midwest had adopted as our building code. So over the years, we had different sections of the United States developing their own code. And as you know, in 2000, the International Code Council came together and wanted to take parts from all these 3 different codes throughout the United States and consolidate them into one model code, which today is our International Code Council model codes. And so that's basically what a lot of what we base our Ohio building codes on and what's used throughout the world as well. So now let's move on to New York City in March of 1911, which was a Triangle Shirtwaist Building fire. 146 people died, 123 were women and 23 were men. And the youngest who died in that fire was only a 14-year-old girl. This was the deadliest workplace tragedy in New York City until that horrible event on 9/11. And the deaths in this case were the results of fire, smoke inhalation, and the results of falling and jumping from this building. This factory business was making shirtwaist garments located in the Ash building in Lower Manhattan. This was a fire that actually started on the 8th floor and spread to the 9th and 10th floor until it was finally extinguished. And again, we had a large immigrant workforce, mainly women, working in these factories. And again, the environments were extremely poor working conditions. This building was compromised in many ways right from the building. Due to the height of this building, there should have been 3 stairwells in the building. Doors from the factory floor should have swung out in the direction of travel. Sprinklers were not required to be in this building, and fire drills were not a requirement at that time in factories. As the architect was designing this building, of course, the architect was working for a private landowner, and the landowner wants to get the most he can out of this property that he has. And so in order to minimize or increase his profits, he wanted to make sure that every floor in that building had the most possible factory space. And so what the architect came up with is, instead of having 3 stairs inside the building, why don't we have 2 stairs inside the building? And let's make one of that stairwell on the outside being a fire escape. Now, that building, the building department did approve that change. The other thing is the doors needed to swing out. But when the architect was designing this building, when the doors swung out into the stairwells, that made those stairwells get a little bit bigger, and said, hey, if we could swing the doors in, we can actually decrease the size of the landings. And again, adding to more floor space on the factory floor. So again, and much of this building was comprised of wood. It was masonry, but it had a lot of wood on the inside of it. So this was a floor plan of the 9th floor. and we have two stairwells, doors not swinging into the stairwells, swinging out. On the day of that fire, actually the floor managers would usually lock those doors during the day because they wanted to make sure that no one would leave these spaces during the day and steal anything from the business. So on that day of the fire, one of the stairwells was locked, and one of the stairwells was one of the location of the fire. On each of these factory floors, we had long tables, tight spaces, and a lot of machinery. The fire started at the end of the workday by a match or a cigarette that was thrown into a scrap bin that was under one of the sewing tables. Basically, as that fire grew, it actually jumped up onto the top of one of the cutting tables. And from the ceiling, they actually had cloth patterns that hung down from the ceiling. So as that fire went from the rag bin to the top of the table, it immediately caught on fire with a lot of these cloth patterns that were hanging down from the ceiling. So that made the fire jump automatically to the underside of the floor ceiling assembly. Once that fire consumed the entire 8th floor, it quickly moved to the 9th floor and on to the 10th floor. And as I said earlier, it was common practice in this time for the factory managers to lock the exit doors. This was to prevent theft from the building. At the end of a shift, managers would unlock the doors and monitor the workers as they were leaving for that day. When the fire was actually seen on the 8th floor, there was a working telephone, but it only had access to a telephone on the 10th floor. There was no telephone line on the 9th floor. The first time the occupants on the 9th floor actually saw the fire was when it was actually on their level. There were two stairwells in the building, but one was locked, and where the floor manager scurried to try to get that open, but that one quickly caught on fire. The only other means out of this floor was the fire escape. Some people had made it up the stairs and were able to get out via the elevator until the heat or the fire actually damaged the cable in that elevator shaft, and it put that elevator out of commission. Many people, actually, the only other means out of this now was out onto that fire escape was at the back of the building. But again, this fire escape is made of iron, and what happens to iron when it heats up from the heat from a fire? It begins to deform. So as that was beginning to deform, every single person that was on, and the weight of all the individuals on that fire escape, it actually collapsed the entire fire escape, and everybody that tried to use that as an exit was killed going that way. Up until this time of the fire, ladders only reached the 7th floor. As I said, the fire started on the 8th floor and moved up to the 10th floor. So the only fire department access was either up through the building or the up to the 7th floor with the ladders. There was over 62 people fell or jumped from that building on that day, and each one of them died. A few tried jumping into the fire safety life nets that the fire department had, but all of those life nets broke under the force from somebody jumping from that height. They did have a fire hose on the floor, but the fire hose was rotted, and had it not been rotted, it still wouldn't have worked because the valve on that fire hose was actually rusted shut. So in the aftermath of this fire, many reforms were made for automatic sprinklers, fire drills, worker safety and workplace environment, fire escapes, and occupant limits. So if we look in today's code, in any type of FF1 factory building, you are required to have automatic fire sprinklers. In Group F occupancies under the Ohio Fire Code, you are required to have fire safety and evacuation plans in place. Worker safety is now mandated by OSHA and the labor unions. Fire escapes still exist today. You aren't permitted to build new fire escapes, but if they are existing, you do have to maintain those. And if you make any modifications to them, they are very limited, but we would find those in today's Ohio existing building code, chapter 504. And then once again, occupant loads are covered by Chapter 10 of the Ohio Building Code. And if you, this was a very interesting book to read. There are also other books on this fire, but this was just, if you want more on this subject, this was a great book to pick up. After this fire occurred in 1913, the NFPA appoints a Committee on Safety to Life. And this committee created the following standards. They actually went back. There was a standard that was created in 1912, 1 year before this committee went into effect. But they went back and they pulled that standard back and they wanted to look at it. And that discussed exit drills in factories, schools, department stores, and theaters. In 1916, this committee put together requirements on outside stairs for fire exits. And in 1918, they started putting together safeguarding factory workers from fire. And the result of this committee in 1913, through these three standards, that really began to lay the groundwork for NFPA 101, which today is the Code for Safety to Life from Fire in Buildings and Structures. Let's now talk about the Coconut Grove fire. So again, this was that first book that many years ago I picked up and read and kind of intrigued me on these subjects of building tragedies. And this happened in November of 1942. 492 people died that night and 130 were injured. But again, as time passes, people seem to forget about tragedies. This occurred 31 years after the Triangle Shirtwaist Fire, and the Coconut Grove Fire occurs. Once again, we're dealing with locked exits that trapped and killed many individuals. This was one of Boston's most popular nightclubs, and it was a one-story building with a basement. At the time of the Triangle Fire, no standards were in place for exiting. But by 1942, when this building was put in place, we did have standards in place for building exits. This building fronted on Piedmont Street, Shawmut Street, and Broadway. This club was enlarged over time as it ended up taking up other spaces on this block that became vacant. And there was also what was known the Melody Lounge that was in the basement. When you looked in the basement of the Melody Lounge, and that was only really accessible as you came in the front door in the main lobby of the building, and then you would come down a set of stairs to this lounge. Once you got down there, the Melody Lounge had false walls made of wooden frames covered with light and wallboard. Behind that wall, there was actually some exits, but if you were in that space, you would not be able to see them because they covered those up behind the false wall. Decorations filled the lounge with fabrics, artificial leather on the walls, and cloth on the ceiling. They also had imitation coconut palm trees on both the first main floor and in this basement area. From the basement area of the Melody Lounge, there was only one obvious exit out. So if you were a patron to this space, you would enter from the stairs off the main lobby and come down into the lounge. Once you got into that lounge area, there was no other means to get out of that basement. The remainder of the basement was back of house, kitchen, and storage areas, and there was another exit door leading to the outside alley, but it was concealed behind this false wall that if you were a patron, you wouldn't know it was there. And then there was a stairway in the kitchen that led up to an exit, but that was only known by staff members. The capacity of the nightclub was around 600 people. At the night of the fire, it was estimated that there were 1,000 people in the club that night. So again, just like we saw in the Iroquois Theater fire, we had an occupant load that was far exceeded, and it really was the building owner's responsibility to make sure that that occupant load was not exceeded. Again, here we have 400 more people than should have been in that building on that night. And so that fire started in the Melody Lounge in the basement. A busboy was holding a match while replacing a light bulb in one of the fake palm trees. So the fire starts in the Melody Lounge and it immediately spreads through the combustible finishes on that ceiling. As soon as that ceiling catches fire, that fire starts up the stairs and immediately takes over the lounge on the grade level. Once it reaches that grade level, because of all the artificial palm trees, because of all the finishes in that building, it quickly moves to the main dining room floor and eventually onto the cocktail lounge. Being that the entire club throughout was filled with combustible finishes, this fire spread so rapidly. Down in the basement in the Melody Lounge, many died trying to use the only stairs the patrons knew. Some employees in the basement were able to guide some through the kitchen exit doors, and some actually survived by going into a large refrigerator in the kitchen. Approximately 100 people died at the main entrance at the Broadway Lounge, and there were some 200 people that were trapped behind the revolving door at the Piedmont Street entrance. The revolving door jammed, and that blocked people from getting out of that exit. And you can see these are photographs from the Melody Lounge with all the combustible material on the ceiling and the one stair that was the only perceptible way out of that space. Contributing factors to the fatalities in this fire again was the revolving door, flammable finishes, not adhering to the occupant load, inadequate exits that were concealed, and some locked exit doors. In today's code, we have a requirement that if you have a revolving door, you are required within 10 feet of either side of that revolving door to put an exit door in, so that if there is an emergency and people should be stuck in trying to get out the revolving door, you actually do have a door that has panic hardware in it, and so you don't have to use the revolving door to get out. If we go to chapter 8 of the building code, depending on what type of space you have, if it's an exit enclosure or exit passageway, you can only put certain types of materials on the interior wall and ceiling finishes. If it's a corridor, again, only certain type of materials are allowed to go in there, and certain enclosed room and spaces. So we have begun to recognize that you just can't go in and start putting anything up on walls and ceilings, because if a fire event, things will burn, and we want to make sure that these materials have certain smoke and fire ratings. Every room or space that is an assembly occupancy shall have the occupant load of the room or space posted in a conspicuous place near the main exit or exit access doorway from the room or space. But again, there are a lot of occupancy spaces that people are compliant with putting these signs up. But again, it does come down to the owner of the building to make sure that they are complying with their occupant load. Exit measurements. If we truly do have a space that only has one way out, we really do limit the amount of occupants that can be in that space. And we also limit the exit travel distance to get out of that space. And then again, many spaces require two means of egress. And so what we want to make sure is that egress doors have remoteness, that they're not next to one another. You don't want to just provide two doors and put them next to one another, because if there is an event at one of the doors, you want to make sure that you have a door spaced far enough apart that the occupants can actually use that door if the first one is not able to be used. And so we have calculations to determine, based on that room or space, how far apart those doors have to be. And in assembly spaces, if we are putting out tables and chairs, we have to also dictate the aisleways around the tables and chairs to make sure that in an event space like this, if there is an emergency, we still are able to provide exits out of a room situation like this. And then egress doors shall be readily openable from the egress side without the use of a key or a special knowledge. So again, Under a panic situation, you need to just be able to know where that exit door and run towards it and not have to think what you have to do. If you are panicked and this is properly installed, you will just lean up against that door and it will get you out of that space. That building does not exist today. All there is a commemorated plaque for that tragedy in one of the sidewalks. And again, if you're interested in this tragedy, Fire in the Grove is an excellent book to read. And again, it was the first book that I read that got me on this interest in building tragedies. So now what we're going to do is we're going to go to the Hartford Circus Fire in July of 1944. And again, this is not a building at all. It's actually a circus tent. But in Chapter 31 of the Ohio Building Code, we do regulate special construction. And under that Chapter 31 of special construction, we do have a place that talks about tents and membrane type structures. In this event, 168 people died, over 700 were injured, and it was the Ringling Brothers and Barnum and Bailey Circus. This canvas big top was coated with a paraffin treatment for waterproofing. It was for what happens is, waterproofing material is expensive. And so in order to save money, what they thought they could do was take this paraffin treatment and water it down with 4 parts of Texaco white gasoline to thin this product out. 1 part Standard Oil paraffin wax. So the canvas sidewalls were made of a thinner material, but they were not treated at all. The fire on this day actually started in an external men's toilet facility adjacent to the main tent. The facility had canvas sidewalls the bathroom facility had canvas sidewalls, but no top. What the theory is that somebody was using that toilet facility during the performance and discarded a cigarette on the ground. And you can imagine what the grounds look like around the circus tent. Also in this area, the toilet room waste paper, sawdust, wood chips, and dry grass were all on the ground. So as the performance was going on inside the big top, that's where all the attention was being paid to, what was happening within the 3 rings. As the fire began to grow in the adjacent toilet room, it quickly spread to the canvas sidewalls of the main tent. The sidewalls, which were a much lighter material, quickly caught fire, and the fire flame moved quickly to the tent roof. The circus did employ seatmen that were stationed underneath the bleachers, and they were there in case there was an emergency. But once the roof caught fire, due to that paraffin wax coating, which was heavily diluted with gasoline, it took no time for that fire to spread rapidly across the big top. Within 10 minutes, the support posts and the ropes were burned, and the big top was beginning to collapse. 2 of the exits in that main tent that were supposed to be there for exiting were actually used by animal chutes to bring them from the cages into the big top. The fire circus extinguishers were inaccessible. They actually had them on site, but they were locked inside a storage unit and were not employed by the circus seatmen. Many people were burned from the melting paraffin wax or were covered when the falling big top came down. Some people actually died from jumping from the top of the bleachers, but most died from exposure to fire and smoke that was within that tent. And in the aftermath, all that was really left were some bleachers and some cages. Today, we require all tents to be fire retardant treated tents. Fire extinguishers have to be located between 50 and 100 feet apart, and fire departments have to be on standby during performances with their lines charged. There also needs to be a dedicated fire watch. Nobody should be standing in the aisles. And because of this, it was the establishment of NFPA 102, which is the standard for assembly seating tents and air supported structures. Even today, when we have tent structures that come into our jurisdiction, if you look in the Ohio Fire Code and the building code, once tents reach a certain limit, you have to actually give them a plan approval. And part of that plan approval is they have to provide you a certificate of flame resistance that shows you that that membrane structure meets the requirements for that material. And that certificate will actually be on the material or fabric when you go out and do that inspection. In the Ohio Fire Code, it says that smoking shall not be permitted in any types of tent or membrane structures. And the only hay, straw, shavings, or similar combustible materials shall not be located within any tent or membrane structure except the materials needed for the daily feeding of those animals. Portable fire extinguishers shall be provided, and fire hose lines, water supplies, and auxiliary fire equipment shall be maintained at the site in such numbers and size as required by the fire code official. And again, when we deal with tents, this is only a small fraction of code requirements for tents and membrane structures. When you go into the specifics, we have seating capacity per person, lighting that is used within these tents, clearly defined exits, and there is a fire watch. And as I said earlier, NFPA 102 that we have today, this was a strict result of the Hartford circus fire. Again, there are a couple books written on this structure, this tragedy event. It was really interesting to read because, again, this was not a building structure, but it was actually a tent structure. But we saw things that were not enforced or working within the code that caused people to lose their lives. Now we're going to move to Atlanta, Georgia in December of 1946, which was the Wyckoff Hotel fire where 119 people died and 65 were injured. This hotel opened in 1913 and was one of the largest buildings at the time in Atlanta. This building was located on the corner of Peachtree Street and Ellis Street. The north and east side of that building had exposure to the street. The south side of the building, which you kind of see clearly on this photograph, was bounded by a two-story retail building just to the south of it. And this building was 15 stories tall and 115 feet tall. Also to the west side of the building, it was bounded. There was actually a 10-foot alleyway between these two buildings, which you could see shaded there. And there was a 12-story mortgage guarantee building just to the west side. At the time of this fire, the available ladder trucks in the city could reach 55 feet, 75 feet, and 85 feet. On the day of the fire, one of the 85-foot truck ladders was out of commission because it was sitting in a repair shop. But still, with these ladder heights, all guests above the 8th floor were completely out of reach. Now, when they built this building, it was actually advertised as being absolutely fireproof. But the definition of fireproof was for property concerns and not for the occupants. Insurance companies at that time identified fireproof construction as that type of building that could withstand a severe fire, but could be returned to service once the interior finishes were replaced. This was a building that was constructed of a steel frame with concrete floors. The walls between the rooms were constructed with terracotta tiled plaster on each side. Because this building was considered fireproof, there were no fire escapes, sprinklers, or any type of enclosed stairwells. There were some tragic fires in the US prior to this event, which caused cities to start looking at more stringent codes. But in 1943, Atlanta passed a new code with retroactive features. Under this code, the Wyckoff Hotel fire would have had to install fire doors and fire escapes. But the city attorney ruled that the building was constructed under a previous code and which could not be required to make alterations. So even back then, even back in the 1940s, there was a recognition that this was considered an existing building. And being that it was approved under an earlier edition of the code, it could remain as it was. So again, this hotel was built in 1913. The 1911 building code at that time required fire escapes on buildings with a 5,000 square foot floor area or more. What was interesting here was this hotel was built on a small lot with an area coverage of 4,400 square feet. So it was actually under that 5,000 square foot threshold. So therefore, because it did not exceed 5,000 square feet, the building code did not require it to have any fire escapes. This building could have been many more stories taller than the 15 floors that it was. And again, it still would not have required to have fire escapes on it because it was not larger than 5,000 square feet of floor area. The corridor was built in an H shape with a central stair and stairway and elevators. There were no doors on that stairwell, and it was the only means to move up and down that building. So you basically had one stairwell going up and down those 15 floors, and that was completely open from the ground floor. That stairwell is completely open from the ground floor all the way up to the 15th floor. Since there was no air conditioning in the buildings at this time, each hotel room above its door had a transom, and those were typically left open for cross ventilation. The corridors were finished with burlap wall covering. You had thin wooden room doors, and the rooms every couple years, all they did was they would refresh the rooms and would just do layer upon layer of new wall coverings or new wallpaper over all old wallpaper. There was a code amendment in 1924 that required fire doors and stairwells, but again, that was well after this hotel was built. To this day, the cause of the fire is unknown, but they do believe it was either arson or did somebody leave a mattress in a corridor on the third floor, and did that catch on fire from a discarded cigarette? So sometime around 3:30 a.m. in the morning, this fire starts on the third floor, and it quickly rose to the fifth floor. Many guests opened their doors due to the commotion they were hearing, and as soon as they saw the fire and smoke, they ventured back into their rooms and opened their windows. Since the doors into the hotel rooms had transoms above them, it did not take long for the smoke and the fire to get sucked into the individual hotel rooms. As the fire is burning on the lower floors, hot gases are rising up the open stairwell, so we have the chimney effect. Since the top of the stairwell above the 15th floor is not vented, the hot gases build up to the underside of the building, and then they start to extend down the stairwell. And when they meet in the middle of the building and they hit the fire, they explode into flashover. This fire spreads from the third floor all the way up to the 14th floor. It did not make it up to the top two floors. With the elevators not operational and the stairwells impassable, the only way out of this building was out the windows. Some were luckily able to escape onto the roof on the adjacent building. So there were a lot of hotel rooms on the west side of the building, and there was the mortgage guarantee building that was only 10 feet away. And so they actually had people in that building that actually started opening their windows and passing ladders across the 10-foot alleyway to let people escape that way. Some were rescued from windows across the alleys. Some on the north and east side were rescued from the ladder trucks. But many people died falling, jumping, or as they were climbing down ropes, which were made out of bed sheets. They failed either under the weight on that bed sheet or were destroyed by fire coming out the windows. This fire lasted 142 minutes from 3:42 a.m. in the morning until it was extinguished at 6 o'clock in the morning. and 119 people lost their lives on that day. This hotel was rebuilt 5 years after that fire, but this time when they rebuilt it, they installed fire escapes in this building, sprinklers throughout, and they started installing fire doors. Each floor was reconfigured and was given three means of egress. We now had shaft enclosed elevators and non-combustible stair enclosures. To this day, this fire has never been solved. So today we see in hotels, there shall be a minimum of 2 exits or access to exits from each story. If you do have an interior exit stairway or ramp enclosures, they shall have a fire resistance rating of not less than 2 hours when connecting 4 or more floors. And again, we look at interior finishes. When we put interior finishes into these areas where we have to use as a means of egress in a fire or a tragic event, we want to make sure that those ceiling finishes and wall finishes meet flame and spread requirements. All our corridor walls shall be fire resistant rating. So any of the walls or doors that separate the hotel room from that corridor have to meet a fire resistance rating. Also, we shouldn't be using that corridor as a supply return exhaust or relief vent. We saw in this fire that once we opened that transom window in the hotel room and we had that transfer of air, it actually brought smoke and fire into those hotel rooms. So in any building that has a corridor, we have to make sure that we're not sharing that air with other spaces. Fire door assemblies have to have minimum requirements of 20 minutes when they're in a corridor wall. And again, in these type buildings, they do need to be equipped with fire sprinkler systems and fire alarm systems. And again, anyone interested on this subject, there is a book out there on this tragedy. So now we're going to go back to Chicago for a school tragedy in December of 1958, and that was the Our Lady of Angels School, where 92 students and 3 nuns died and many more were injured. This was a Catholic school in the Chicago area. It was a 2-story building, which was connected to another older 2-story building. And there was a annex between the 2 buildings. Unfortunately, these 2 buildings were connected by open stairwells with substandard doors. About 2:30 in the afternoon at the end of a class day, this fire breaks out at the bottom of one of the stairwells. There was some speculation that some of the students may have been smoking in that stairwell and deposited a cigarette butt in a trash can that had some combustible material in it. As this fire intensified, it actually went up the stairwell to the 2nd floor, and the hot gases and smoke quickly began filling the 2nd floor corridor. These hot gases ignited combustible interior finishes, and the heat was so intense that it actually broke the transom windows above the classroom doors. Once those transom windows broke, the fire immediately started to enter those rooms. There actually was a fire alarm system in the school which was activated, and the occupants on the 1st floor got out. But the students and nuns on the 2nd floor became trapped. Students were rescued from the fire department through some of the 2nd floor windows, but many of the students died in the classroom. Some were actually found still at their desks when the fire department actually got into these classrooms. This building had a raised basement, and each floor had 12-foot ceilings. So jumping from the 2nd floor was pretty risky because you were looking at something over 25 feet. The contributing factors in this fatality was we had open stairwells, flammable interior finishes, an inadequate fire alarm system. There was actually no fire blocks in close proximity to the school. We don't really have those anymore today. And actually the glass transoms above the door were not fire rated glass. And so they melted under the heat and allowed hot gases and fire to move into those classrooms. So today, again, when we look into the codes, when we're building interior exit stairways and ramps, they have to be constructed safely as exit shafts to get us out of those buildings. And again, we're talking about wall and ceiling finishes in Chapter 8. In any type of school building now, we do require them to have a fire alarm system. And not only does it have to have a fire alarm system, but that fire alarm system has to be monitored and be able to communicate with an offsite fire department and an offsite security monitoring company. And again, when we're constructing these type of corridors, we have requirements for building those fire rated assemblies. Again, To Sleep with the Angels is an excellent read regarding this horrific tragedy. Now we're going to go on to the Beverly Hills Supper Club fire, which was down in Kentucky. What was interesting, there's a lot, when I was reading into this, what I found interesting, because I'm from the Cleveland area, there was a lot of Cleveland mob activity in this area at that time. During the 1930s up until 1970s, the mob had control over the business happenings in this actual supper club in the Kentucky area. In the 1970s, new owners took over the club and they decided they were not going to pay off the mob. The building was set ablaze by the owners, not by the owners, but it was set ablaze by the mob, but it was rebuilt. What was interesting in the Kentucky area during the 1970s was that there were actually 45 bombings of nightclubs, 60 murders, and 40 arson fires, all related to the mobs having control over a lot of these nightclubs. So this event happened in Kentucky in May of 28 of 1977. 169 persons died, 200 were injured. At that night, John Davison was expected to perform that evening. And because of that, it was a large draw and they had many people, I think much more than should have been allowed in that facility. This building at that time had no automatic fire sprinkler system or fire alarm system. And in February of 1976, the state fire marshal had stated that this building was in ship-shape condition with no major violations. What was interesting was that in 1975, alterations and additions were made to this building, but no permits were ever required. The owners felt that these alterations were minor in nature, and therefore they just felt they didn't need to exceed approval. I don't really have any overhead shots of what the building was before the fire, but this was the overall shot of the building after the fire. And you can actually see, based on the size of those cars in the parking lot, that this was a huge facility and all of it was basically an assembly space. In 1974, there was a major addition that was added onto the original structure, but the required fire exit for that addition was omitted during construction. In 1975, other alterations occurred, but permits were not required because the owner felt that the minor changes in the building didn't require any permits. What was interesting is they had an existing storage room in that building that they weren't really using, and they said, well, let's take that storage room and convert it into another banquet room. So what happens when you take a storage room and you convert it into a banquet room? You now increase the occupant load in that building. But they just thought it was an existing space and we're just going to use it in another manner, not realizing that now they were increasing the occupant load in that building. This building had multiple party rooms of various sizes, and on the night of the event, it was estimated that there was 2,600 guests that night. Now, a few days prior to this event, there was an HVAC crew and a cleaning crew in the building. It was believed that after this event, that the HVAC crew was actually there to install a device to trigger a fire in that building. Witnesses stated that that cleaning crew was wiping down the walls in the main corridors throughout this facility, and that cleaning agent that they were using had a very strong chemical smell to it. It was later believed, when they did the investigation on this fire, that that was actually an accelerant that was placed on the corridor walls because of the flame patterns that they found in that area. So sometime on that night, around 5 p.m., somebody working in that facility hears a gunshot sound coming from the basement and smells a bad odor, but nobody really, as they were looking around, were not really able to find anything out. It was believed that what that gunshot noise actually was an electrical device that was actually triggered in the basement below the zebra room, and it actually started a fire within one of the ceiling spaces. What's hard to believe about this, and it just goes to show how tight the construction in this building was when they looked back on this, this fire, you have to understand, this fire started smoldering sometime around 5 p.m. on that evening. And it starts smoldering within a wall and ceiling space. And over the next few hours, some sea smoke rising from the roof of this building, but no one really seems to be alarmed. Inside, some of the witnesses that were there, some guests recall seeing smoke at the light fixtures at the ceiling levels, but they just contributed that to all the people that smoked in those banquet rooms during that time. At 9 p.m., staff determined that finally at 9 p.m., so this is 4 hours later, this fire has been smoldering inside some of the wall cavities and ceiling space. And it's not until 9 p.m., 4 hours later, that they actually see fire in the zebra room. The staff start to move throughout this entire building because, again, we don't have a sprinkler system or a fire alarm system. So the staff start to run through all these banquet rooms, and they start to just inform the guests that, hey, you need to get out of this building. There is a fire. The fire department arrives a little after 9 p.m. and assumes at this point that most of the people are out of the building. It was estimated that when the fire department pulled up at 9 p.m., there were still 1,200 people inside that building. By 9:30, half an hour after that, the building is fully engulfed in flames. At midnight, the entire building roof starts to collapse, and by 2 a.m. in the morning, that fire is under control. But many people died in this event because they refused to vacate the building when they were instructed by the staff. Changes as a result of this tragedy in 1981 edition of the NFPA 101, new and existing assembly occupancies with occupant loads exceeding 300 were required to go back and put fire alarm systems into these spaces. Buildings of this size were required to have a fire sprinkler system. And we can see this in OBC section 903.2.1 and 907.2.1 for Group A occupancies. Nothing exists on that site anymore except these memorable plaques to commemorate that horrible event. And again, anyone interested in learning about this subject, you can read about this in the Beverly Hills Supper Club by Robert Webster. So now a little later on, we have the MGM Grand Hotel and Casino fire in Las Vegas. This was the second worst hotel disaster fire in the United States. The first was the Weinkauf Fire Hotel that we just talked about before. So this happened in November of 1980. 85 persons died, and this was mostly through smoke inhalation. 650 people were sent to the hospital. This fire actually occurred on the first and second floor within the casinos, but most of the deaths occurred on the upper floors due to smoke. This was not a fully suppressed building. There were only some sprinklers in various spaces of the building on the ground floor. During the construction of this casino and hotel, the local fire marshal really pressured the owner to sprinkler the building, but MGM only agreed to do some select areas. At that time, the cost of construction for this entire hotel and casino was $106 million. The cost to sprinkler this entire facility would have been $192,000. That was less than 1% of the entire cost of construction. But again, the code at that time did not require sprinklers in hotels or casinos. There was a deli in the hotel and was expected to operate 24 hours a day. And as such, because they thought it was going to be open and occupied, they felt that that was one of the spaces that there was no reason to sprinkler. What ended up happening on the day of this event was there was an electrical ground fault inside the wall in that deli area that caught fire. Fire started and quickly spreads throughout that area because there were no sprinklers. As the fire actually makes its way in the casino area, of course, as we know what these casinos look like, they are so plush with combustible furnishes and a lot of gaudy interior finishes. We have foam padding, molding, and very large open areas for the fire and smoke to spread rapidly. Back in 1980, there was no such thing as a smoke damper. There were fire dampers installed at that time, but fire dampers do not work under airflow. And the elevator shaft acted as a chimney for the smoke. It was found that in investigation that had there been sprinklers in that deli space, one or two of the heads probably would have activated and the fire would have rapidly been extinguished. Again, the fire occurred on the first and second floors, but smoke from this fire, because it was so intense due to all the combustible finishes within the casino, that fire traveled right up the elevator shafts, up the stairwells. Because we were out west, there were seismic joints in the building, and we also had laundry chutes. As I said, smoke dampers did not exist at that time, and fire dampers will only work if there's a fire. They won't close under smoke. So in today's code, we find out that elevators, dumbwaiters, other type of hoistway enclosures shall be treated as shaft enclosures. Elevator hoistway openings and lobbies shall be protected. So we now recognize that if there's a fire, we want to make sure that these elevator shafts do not work like chimneys. And then in a lot of these hotel buildings, we have waste and recycling and linen chutes that go down between all these floors and are accessible from each floor. So all those type of chutes have to be enclosed in fire rated assemblies. An automatic sprinkler system shall be installed throughout all buildings that have more than 1 stories and an occupant load of 30, located more than 55 feet or more above the lowest level of fire department access. Other changes as a result of this fire in Las Vegas: we now locked stairwell doors have to open in an alarm status. So a lot of times you will go into hotels and you might have only access to your floor, but in an emergency, you have to be able to use that exit stairwell from all floors. And so you want to make sure that if a fire alarm goes off, all those doors will automatically unlock. Stairwells need to be pressurized from smoke entering in those enclosures. HVAC systems have to automatically shut down so we aren't transferring that smoke to other portions of the buildings. And fires like this have to have an emergency evacuation plan. So again, overall, after we had the Iroquois Theater fire, we did start to see improvements in theater safety. After the Triangle Shirtwaist fire, we started to see improvements in factory safety. Nightclub safety after the Coconut Grove fire, and improvements in hotel safety after the MGM. But again, we still today see tragedies when codes are not enforced. I'm sure everyone is aware of the Roadhouse Island nightclub fire, which occurred in February of 2003. So that's 61 years after the Coconut Grove fire in Boston. And once again, another horrible event. But many of the same things that happened at the Coconut Grove fire happened in Rhode Island, and they shouldn't have happened, because now we have codes that are clearly in place to prevent things like that from happening. Sometimes when they've gone back and looked at some of these tragedies, were codes overlooked? Was there a lack of proper enforcement? In some of these tragedies, codes were in place, but bribes were taken and things were overlooked. When some of these incidents finally did come to court, many fire and building officials were found not guilty of properly enforcing the code. And again, some of these events could have been prevented with proper code enforcement. Now we're going to move into the last section of the day, and you'll be out of here shortly. But I wanted to talk to you a little about the code development process, because a lot of times we think when we're out there that the only reason we have code sections is because some tragedy has happened and some event has occurred, that tragedy, to cause us to make a code section. But actually, you would be surprised when you attend the code development hearings. I attended my first code development hearing in Detroit back in 2005, and it was a whole different, unique experience. I never imagined what really goes into making that code book and what actually happens behind the scenes. I wouldn't say behind the scenes because it is a public process for all of us in the code development process to attend. But when you go there, you will actually find out that not all code changes are the result of tragedies. There are many manufacturers out there who would like to get their product in every single household in the world. And how do you do that? You go ahead and you create a code that would require each dwelling structure or building to have that device. There are many manufacturers out there who will actually go and hire code consultants to come up with code languages that will support their project, and that gets presented at the code hearings. So over the years, I have gone to many of these code hearings just to hear what the history are, or what's the reasoning why somebody is trying to get it into the code. And a lot of it is most of it is product developers. They have a device that they feel, a safety device or something that they come up with a reason why it should be a safety device and why a house should have it. And you would be surprised that a lot of these do get turned down, but some of them actually are successful and move forward, and people make a lot of money getting their product into the code. And so it's not always just code officials and fire officials who are sitting at the code development process. There are a lot of people in the industry who come to these events just to get their product in our code. But you as an individual, you yourself can actually make a change. It doesn't, you don't need to be a code consultant. You don't need to be a manufacturer. Back in 2006, we had the first residential code of Ohio came into play. And it wasn't until 2013 where we actually had our first major update in that code. And what actually happened in 2013 was there was this code on exterior walls that was pulled from the commercial code. And what this code, this table did was that as our structures on residential properties, if you were in 5 feet or 3 feet or 1 feet to a property line, you now had to comply with this code section. And at that time, up until this time, you could basically build anything on a residential lot up to 3 feet to the property line without having to have any type of fire rated construction. Well, when this table was introduced in 2013, now it told us that you had to be anything less than 5 feet to a property line was required to have a 1-hour fire resistant rated wall assembly. Well, at the jurisdiction that I was working with at that time, most of 80% of my lots in my jurisdiction were 50-foot wide lots. And so it was hard to build a garage. Most of our garages were built 3 feet off the property line. But now under this code, in order to get away from this code requirement of having to have a 1-hour rated wall, you now had to set that garage 5 feet off the property line in order to be in compliance. Or you could keep it less than 5 feet, but now you're building a 1 hour rated wall on a detached garage. And that was really getting pretty expensive. It was not just my jurisdiction that was having this problem. I started hearing from a lot of other communities in the Northeast Ohio area that were having the same situation. And so I took it upon myself to see if I could make a code change. And so I basically went to the Board of Building Standards website and I downloaded this application for a rule change. And what I was asking for was that I didn't have a problem with the actual dwelling structure having to meet that requirement. It was if it was less than 5 feet, but on a detached garage or a detached shed in the backyard, it seemed kind of onerous to have a 1 hour rated wall. And so I downloaded this application and I filled it out and I submitted it to the Board of Building Standards and I had my hearing. And today in the Residential Code of Ohio, under section 302.1, the exception number 6 basically states detached garage accessories to a dwelling with an exterior wall located greater than or equal to 3 feet from a lot line does not have to meet the requirement of that table. And so I proposed that change and I stated why I felt that change should be made. And I actually got myself a code change in the Ohio codes. And so this is kind of my, as I said, every little code section has its own history. This is my little history that I like to talk about in the Residential Code of Ohio. So we have the option as individuals to make code changes if we feel that there needs to be a code change. Hopefully, this presentation showed you that there really is a story or event behind each code section in that book. Again, this presentation only covered a mere fraction of the historical events that are out there. But I think when we learn from our mistakes and in doing so, over time, we have developed ways in which to provide safe environments. And I think when we have the knowledge of knowing the history behind the codes, it adds more perspective and understanding the importance of the codes we are out there enforcing. And I can't tell you, I love it when I'm out in the field and a contractor or sometimes an architect asks me a question about why is this code out there? Because I love talking about the code. I really like to explain to them when they say this code really doesn't make sense. And I said over the years, I've been to multiple code hearings. Right now, we're going through a period as we're transitioning into these new codes. There's a lot of stuff to know with these code changes. And it's interesting to get out there and be able to explain why that code section is there. Because I think once somebody really understands the meaning behind it, they remember it. And then you don't have to worry about it the next time they try to go out and build something new. They know that they have to meet that code requirement. So I like to go back at the end of this presentation and say, you know, do we want our building departments to be known as a center of regulation where we just go out there and say, because that's what the code says? Or do we want our building departments to be an information center where we actually go out there and say, let me explain the background and the intent and basically the history of why we're enforcing this code? So I come back to that first slide, you know, can building codes be interesting? I hope I showed you today through this presentation that yes, I do find building codes interesting. And I think over time, the more meaning and the more history we can find out about the codes, the more meaning they hold. And with that, I'm just going to end my presentation. This is your last presentation for today's class. And so hopefully you got something out of this presentation. And I just want to wish you good luck with the rest of your Code Academy.
Well, thank you so much. Thank you so much for a really informative presentation. I know that it can be heavy and it can uh, revisit some tragedies in our own lives. In fact, we have one class member who was actually at the Supper Club fire, and his group was killed in that fire. So uh, these are tragedies that impact everyone's lives, and I think that it's really important to remember that this profession that everybody is entering into here can prevent tragedies from happening in the future. This is the only preventative public safety job there is. And so I commend you all for being here and for undertaking this great task. And Paul, thank you for doing it for so long and for also presenting such a wonderful presentation.
All right. Well, thank you very much. And as I said, thanks, Meg, again for proctoring all of this. And I hope everyone gets out a lot over the next couple of days. And there's a lot of interesting stuff out there. So good luck the rest of your Code Academy.